All right. So this video applies to multiple modules. In the MW course, we're going to do 3 very big optical astrophotography projects. One during one dark cycle, one during another dark cycle, and one during another dark cycle. During the first one, we're going to study star formation, star birth. And so we're going to image and explore star-forming region. In the second one, we'll do star death. So things like planetary nebulae, maybe a supernova remnant. And in the last one, we'll do galaxies. And in these, we're going to burn a lot of telescope time. And telescope time is not cheap. It's expensive. So in this video, I'm going to show you how to prep, how to plan, how to prepare, how to put in a test observation. So in the next video, when we put in the main observation, we do so as efficiently and as effectively as possible, not wasting a lot of telescope time, not wasting a lot of money. So I'm going to just show you kind of the gist of it, and then we'll go back and sort through all the details in this video. Now, what I have up at the moment is Stellarium, free software. You can download it onto your machine. And when I downloaded it for the first time, I couldn't figure out how to minimize it, which can be really annoying. So just so you know, function F11, I guess I have to be clicking on the screen there. F11, I can minimize it. And here, I'll maximize it again, just so you can get to other things. Okay. Now, first of all, you have these 2 pop-up tabs. You can lock them into place by hitting these buttons here and there. And we're going to be looking at different targets, and we don't want to worry about the Earth or the sky. We don't have to keep changing our location or changing the time of day so we can see our target. Let's just get rid of the ground. That's this button here. And let's get rid of the atmosphere. It's this button here. Okay. So we have the whole sky here. You can zoom out and, explore any part of it. Over here is where you find objects. And we'll talk about selecting a target in a little bit. But let's go to a popular one, the Horsehead Nebula. So it's right there, and I'm going to zoom in. There it is. In Stellarium, you have kind of these overlays, kind of low quality images of a bunch of popular targets. Any star forming region or galaxy or star death region that we image in this course probably has a little postage stamp in here. Here's one, here's the Orion Nebula. Over here we have Messier 78, Reflection Nebula. It's called the Flame Nebula here. And of course, the Horsehead. Anyway, let's say we're going to image the Horsehead. And since I was moving around, probably see the sky's moving there. If that happens, you can just come back and recenter on it. Now, when designing an observation, once you found your target, you're going to want to be able to visualize your telescope's field of view here in Stellarium. And we do this with oculars. And in a moment, I'll show you how to set these up, but this is the ocular button right here. And it's currently set to prompt 5. I'll set it to the prompt 6 sensor and the prompt 6 telescope. Okay. And again, you got to code in all the different prompt telescopes you may use or some other telescopes you may use. You code it in here. And when you do that and you set the sensor, your camera, and you set the telescope, then it will draw a box. And that box is the field of view that your telescope will image. Now, if you come down here, this little telescope icon, you click on that and just rotates it into the right ascension declination coordinate system, with right ascension running across the bottom, declination running up and down. It gives you a little bit more space to work with. You can zoom in a little bit. And then basically it's a matter of framing it up. You frame exactly how you want it to be positioned in your image. It may be perfectly centered, but maybe you want to get some other details, like perhaps that star. Maybe you want to instead image this reflection nebula. I'm just going to do a traditional kind of something like that. Okay. Now, before we can code in the oculars, we have to think about the telescopes that we want to code in. Let me minimize this for a moment. And here I am in the optical observing guide. And here's a list of telescopes that are good for astrophotography. And I'll update this, each year. This is just the list I currently have in there. So let's take a look at these. Up in this first category, prompt 5, prompt Meckering, prompt USASC, also prompt 2, they're all identical systems. Prompt 5 and also prompt 2, they're at Cerro Inter-American Observatory. That's our best site. By far, the atmospheric seeing is exquisite, so very low atmospheric blurring. It's dark, and so that may be a site you want to consider. Of course, you have to be observing a southern hemisphere target for that. But prompt Meckering's in Australia, prompt USASC is up in the northern hemisphere in Canada, giving you different coverage. Now, some drawbacks. These telescopes are also used by the OPUS curriculum. And the OPUS students image a lot of bright planets. And those bright planets leave ghost images, little residual images in all following images. So they're just hitting planet after planet, leaving little ghosts, little blurs in your images. So you may want to avoid these telescopes if you're worried about that. Now, if you get a ghost in 1 or 2, it's not a big deal. We'll be able to remove that as long as you have a lot of images that didn't have the ghost. So I'm not saying avoid these telescopes. And they do have the advantage that they're small, 1K by 1K. That means they'll be faster to process. But they do have a small field of view, only 10 arc minutes, and kind of largish pixels. Now, let's see. We have the Prompt 6 telescope. This is kind of the go-to telescope we have for astrophotography. It's in the Chilean site, so great imaging conditions. More pixels, it'd be a little slower to process, but it's nice to have all those extra pixels when you're making a nice, pretty picture. Slightly larger field of view and smaller pixels. So, more pixel resolution. Then we have the Prompt 7 telescope, and you probably don't want to start with this telescope. We only have it during bright time. Now, all these astrophotography projects, the big ones, we'll do during dark time when the moon is close to new. We only have Prompt 7 when the moon is close to full. So it's probably not the first telescope you go to, but you'll do your test observation, you'll do your main observation, you'll look at your images, you may want to add some more data, you may go back and get some. And by the time you're wrapping up, we're moving into bright time. And Prompt 7, we then gain access to it. There's still some dark periods at the beginning of bright time, at the end of bright time. You can use it. Also, narrowband filters. You can use in bright time, not all the way during full moon, but part way into bright time, you can use those narrowband filters. And so you may want to use Prompt 7 to kind of bat cleanup and get some additional observations, but you probably don't want to start with it, not at the beginning of dark time. And also Triple RT. It's not a prompt telescope, but it's a nice telescope. It's in the Northern Hemisphere, giving you another Northern Hemisphere option. Both Prompt 7 and Triple RT have very large fields of view and lots of pixels. Okay, so some telescope options. And again, check this because this list will update and change on an annual basis. Now, coding in oculars. I'm going to show you how to code one in, but you probably want to code in all the oculars you have here eventually, so you can choose between them. So let's go back to Stellarium. And to code in a new ocular, use the gear symbol. And we have to code in the telescope and code in the sensor. So I'm going to go to the telescope here, and I already have them all in here, but let me just code up let me code up one I don't have. So you go here, you add, and what telescope do I want? Let's pick one that I don't have in here. So I'm going to Skynet. All the information we need to code in the telescopes, to code in the sensors, the cameras, it's over here in Skynet. Go to telescope sites and pick a site. I'm going to code in another Northern Hemisphere observatory. This one hasn't been online for a while, but when it is, it can be quite nice. So let me build an ocular for it. Again, I recommend you code in the prompt oculars and triple RT. I've just already coded all those in, so I want to try something different here. So I'm going to go to Northern Skies Observatory. It's called NSO 17 CDK. So I'm going to name it NSO-17-CDK. Okay. And we just need two numbers to code in a telescope, focal length and the diameter. The units don't matter, it just has to be the same unit. So I come over here. It says for NSO 17 CDK. Let me click on that telescope. Here's the information I need. It has an aperture of 0.4 meters and a focal length of 2966 millimeters. So I got to get those in the same units. I'll take my 0.4 meters times by 1,000 to get into millimeters. That's a 400 millimeter aperture. That's the size of the mirror, the diameter of the mirror. And the focal length is kind of defines the optics, how much magnification you'll get. So let me slide that over. I'm going to code in these two numbers. For the diameter here, that's the aperture in millimeters, it's 400. And the focal length, 2966. Okay, so that telescope is now coded in. If I go over here, I can probably find that telescope. I have to close this. There it is, NSO 17 CDK. And it has a bigger field of view, but I have the wrong camera on there. I have to code in the camera as well. So that was the telescope. Go to sensor, and I'm going to call this NSO 17 CDK sensor camera. And most of this we don't need, just the first four numbers. Resolution. So I come over here, and this one is a 4K by 4K. That's 4,096 pixels on a side. So the first number is 4096, and the second number is 4096. Okay. So we have the resolution there. Now we just need the chip width and height. So to get that, to get the width, you take the first number here, bring up a calculator, 4096. It's 4096 pixels. I'm going to multiply by the size of the pixel. This is in microns. These are small. Times 9. So that's the size of the chip in microns. And I need it in millimeters. So I'm going to divide by 1,000. Those are 36.86 millimeter chip. You got to do both of them here. So I mistyped that. 36.86. 36.86. Okay, that's a really nice field of view. They do a lot with that. And here I have the camera set to it, and I have the telescope set to it. Now, alas, that one's not available right now. Here's the triple RT. It's pretty good sized. I don't know if this target's observable from triple RT. I'm going to find out. If so, I like that framing. It's pretty good. Okay. All right, let's see what's next. Now you know how to set up oculars and which telescopes to set them up for. Time has come to pick our target. Now, in Module 3, it has a list of targets. Module 5 has a list of targets. And Module 7 has a list of targets. Let's see. Right now, I have the Module 3 target list up here. This is Module 3. And you can see I have a list of targets you can choose from. And they have the right ascension, the declination, and the brightness. And though take the brightness with a grain of salt. Sometimes it's the brightness of the nebula. Sometimes it's the brightness of the brightest star in the nebula. That's why we're going to do a test observation. And also the size of the nebula. And for many of these nebulae, they are bigger than the field of view of your telescope, in which case you're going to want to image a portion. You'll frame it on the sky very carefully. Now let's see. I selected the horse head. It's right here. And in these tables, there are links to Wikipedia pages. And so you can examine other people's, another image, learn some stuff about it. Here's some other images here. You can Google it. Let's try that. Images, and some of these were taken by Hubble and Webb, and some of these were taken by backyard astronomers. You're going to make something kind of in between. But go through the source list and find something that interests you, research it. But then you got to check, is it currently observable? And if we go to the observing guide, slide up here. By the way, here are the instructions on how to set up the oculars written out. Come up here, you'll see a table. At any given time of year, about half the sky is not really good for observing because the sun's there and brightens the sky. So think about what time of year it is. And we're just doing a test observation now. We'll submit the main observation in a week. Looking right now, when I'm filming this, it's the very end of January. So we'll be submitting our main observation in early February. And so something kind of between these two. So I guess I want my target to be between 4 hours right ascension and 14 hours right ascension. And the closer you are to the middle, the better. If you're too close to one side or the other, it's only going to be observable for a short period of time at the beginning of the night or at the end of the night. And so you won't have as much time to collect your data. Okay. And the horse head, according to that table, 540. So good. That's within my window for this time of year. That's what I'm gonna image. Okay. Well, checking my notes. So I've selected my target, my telescope, I've framed it up. And the next thing I need to do is get the coordinates. Framed it up pretty good. So the coordinates are right here. Make sure it's in equatorial mode, and the coordinates will be in the upper left. And they're written in red, which is sometimes hard to see. And I'm going to write them down. You got to get them perfect. If you type in a wrong digit, you'll image the wrong part of the sky. I'm just checking them. Okay. Yeah, I've written them down. Okay, so now that I have them, I'm going to go to Skynet and set up a test observation of this field. So here's Skynet again. Going to go to optical observing. Done this multiple times before. Add a new observation. And you can start with the keyword horsehead. Now, the keyword doesn't always work. Didn't work here. So we need the technical name. Spell or type. Horsehead Nebula. It's got to have an NGC number. Appears to be NGC 2023. Anyway, let's see if that works. Appears to be the right part of the sky. Loads an image. Maybe it was in 2023. Well, it got me close anyway. That may be that reflection nebula next to it. It doesn't matter. I wrote down the coordinates and I can adjust them. 541, 29.47 minus 2, 20, 38.8. Okay, so that was just to get close. Now I've typed in the coordinates corresponding to the center of this field, these coordinates right here. The first set's the right ascension, the second set's the declination. Double checking them, really important to get them right so we don't waste a lot of telescope time looking at the wrong part of the field. And I'm going to add to the observation name _test, just to keep track of that. Now, the settings here. Let's switch, in module 1, when we were looking at bright things like planets, we used -12. Now we're going to go to -18. This is when the professionals wait for the sky to get truly dark. That's -18. Let's start with a min target elevation of 30, making sure our target is high enough in the sky. Again, if it's too low, we look through more atmosphere with more atmospheric blurring, though we'll have to check the air mass chart below, see if this is going to work out. Fan mountain. Yep, I'm blinking it. I don't know if you can see it. It's this curve right here. So indeed, it's observable for a good swath of the night, 4 or 5 hours. So that's great. If it's not to your telescope that you're interested in, you could try lowering the target elevation. For example, if I switch to 20 and click off the box, that lowered the gray bar. So now it's super observable, but I'm going to put it back at 30. I don't want to image that low if I don't have to. If it doesn't work for your telescope, you're probably imaging a northern hemisphere object with a southern hemisphere telescope or vice versa. And you may just have to swap your telescope and go back a few steps and reframe it, etc. Min visible hour. If it's not visible for at least an hour, you should pick a different target. Because, the telescope's used by many people. What are the odds that you're going to get it during that hour? And data will come back more slowly. Again, check the air mass chart. Make sure it's good for a couple hours. Now, moon phase, let's set that to 100. We won't for the main observation, And we're going to want to make sure we're observing in dark skies. But for the test observation, it can be crappy. So we're willing to observe right up to a full moon as long as the moon is 30 degrees away. When we do the real deal, we'll lower this tremendously and make the moon be even farther away. This is good for the test observation. We won't use this in our final image. This is just planning preparation. We don't need any of these advanced settings. We've already checked the air mass chart. I'm doing triple RT. I usually use prompt 6, but I'm going to use triple RT because I like that bigger field of view. That was Fan Mountain Observatory. Let me close some of these other ones so you can see it a little bit more easily. So there it is. See it right there? Observable for 5-ish hours. Okay. Next, I'm going to choose telescopes. And just check here. Yep. And I want the triple RT. Make sure no other telescopes are selected. For this and most of the remaining observations in the course, you will be designing them for a specific telescope. So I'm going to design it for that one. Triple RT. And then I'm going to save and continue, and this takes me to the filter page. Now, the filters you want, come down here to Johnson, Cousin, and astrophotography. Let me turn them all off for a second. You want definitely LRGB, a luminance filter, which collects a lot of light, gives us high signal to noise. BVR, those are going to be our color filters. They mimic the human eye pretty well. There's some other options. There's something called red, green, blue that you can use. But if you have BVR, go for that. And then we want some narrowband. There's a lot of physics and a lot of good science and a lot of good imagery that comes out of the narrowband. And we use these when looking at bright objects like the moon or Jupiter. But that's not what they're really for. H alpha is for looking at hydrogen. O3 is for looking at oxygen. And oops, I want my H alpha. And there's another one called S2. Now, it's not on this list because this telescope doesn't have one. So I won't get any S2. Oh, well. But something you may want to get. If your telescope has it, select it. Okay. And save and continue. Takes me to the exposures page. So let's, the telescope should be set to your design telescope, not the generic, but to the telescope you just designed to. And let's add some rows down here. And we're going to put our filters here. Now, word to the wise, put your narrow band filters first. For me, it's H alpha and O3, also S2 if you have it. And then do your regular color filters, B, V, R. Gonna go from blue to red. Doesn't really matter. So O3, H alpha, BVR, and then your luminance filter. We do this for ghosting. Since the narrowband filters don't let through a lot of light, they don't leave aggressive ghosts. And so you start with them and you won't have aggressive ghosts in your BVR, and they won't leave an aggressive ghost in luminance, which collects even more light. If you do it the other way around, luminance brings in so much light, you could leave a ghost in your BVR, and that's brighter than the narrowband, so you can leave a ghost in that. Now, still, if someone observes something bright before the start of your observation, you will get a ghost in your narrow bands. But as long as it's not in every narrow band that you eventually take, we can get rid of it. Now, for this observation, we don't really care. This is just our test observation. We're going to make sure that the exposure durations are the right level so we don't saturate stars. We're going to look at the narrow bands and say, is this one even worth spending a lot of time on? Maybe get rid of some. So if you have some ghosts in this test observation, it doesn't matter. But still, you should get used to this order. Narrow bands first from blue to red, color filters from blue to red, and then luminance. Now for the test observation, we just want one of each. Okay, and our starter durations, we're going to take a guess. The narrow bands, let's set those to 300 seconds. That's about as long as the mounts can track accurately. Oops, I just have two. You have S2, also do one 300-second exposure in S2. 300 seconds is 5 minutes, so I'm wasting 10 minutes of time right there. Okay, so they're very expensive. Narrowband is very expensive. And then BVR should be 80, 60, 40. The light comes through more in the red channels than the blue channels, so we have to image a little bit longer in the blue. And light comes in most in the luminance. It captures like all the optical light. Let's do 20. Now these are not going to be the right answers, but it's a good starting guess. And we'll look at the images that come back, measure some of the bright stars, and decide whether we need to increase or decrease the exposure time. Okay. Then save and continue. Let's see, I got a warning. This field contains a very bright star. To prevent saturation, we have set the maximum exposure times as shown. Okay. Oh, that's fine. Everything's fine. I just forgot to select a time account with enough credits. Okay. This time account only has 27 credits. That's not enough. So let me switch time accounts. Okay. Save and continue. Good. Submit. Okay. It's active. And you're going to want to come back and check this daily and make sure the observation's good. Now, some of the narrow bands may not turn out. It could be that your chosen target doesn't emit in that narrow band wavelength. But, you know, if your red, green, and blue and your luminance come out bad, maybe it was cloudy, maybe it was partially cloudy. And so if it's cloudy, you basically get a flat. It looks like a flat. You see the manufacture pattern of the chip. You see dust. Let me show you a picture. Yeah. So if your images come back looking like this, or here's partial cloud cover, see the out of focus dust, you see the manufacture pattern here, just resubmit the observation. Or, you know, if it was taken at different times and some are good and some are bad, submit the ones that were bad. But do this right away because about a week from now, we want to have good test observations that we can adjust the exposure durations for. Again, here's an example of a ghost. Someone looked at Jupiter beforehand. But again, with these test observations, we don't care about that. Okay, that's it for this video.